When we solved the system of equations using the graphing method, we saw that each equation represented a line and that the solution was the intersection point. So this really leads to the different cases for systems of equations. So the system can have exactly one solution, and this occurs when the lines intersect at a single point. And this is the most common type. The system has no solution. So this would occur when the lines are parallel. So parallel lines do not cross, and if the intersection point is the solution, then there's going to be no solution because they never intersect. And then the third case is that the system has infinitely many solutions. And this occurs when the lines coincide, or they are the same line. So if you draw the first line and then the second line just goes over top of it. So they want us to use the method of our choice to solve the system or show that it has no solution. If the system has infinitely many solutions, we need to express it as an ordered pair. And I'll talk a little bit more about what that means when we get to it. But I want to solve this, and I'll use the elimination method. Now, I can't just add these up directly because none of my variables will cancel out. So let's choose to get rid of the x's here. So I really want a negative 3x because that would cancel out with a 3x. But I'm not allowed to just put a negative 3 there. To put a negative 3 there, I need to multiply the entire top equation by negative 3. So that's going to get me negative 3x minus 12y is equal to negative 24. Then I have 3x plus 12y is equal to 2. And then I'm going to add these up, and my x's go away. Now, my y's go away as well, so that's going to leave me 0 on this side. And then I have negative 22 on the other side. So this is a special situation when all of the variables go away, you're left with a statement, and that statement is either going to be true or false. Well, this is a false statement, so this means that there is no solution. These are parallel lines.